So my name is Sandeep, and I have over 3 years of experience in developing serverless applications, and I currently work in Stack as an engineering manager. Now, before we get to the application itself, so one of the first questions that's going to come is why serverless, right? So as you may or may not already know, so serverless is one of the fastest ways of application development, and it's much more easier because most of the infrastructure abstraction is done using the serverless architecture. So you get more time to focus directly on the business logic rather than focusing more on the infrastructure and things like that. And in today's session, we'll see how what are some of the commonly used serverless services and how we'll be using them to build the application. So let me present my screen and start. Yeah. So today we're going to build a leave approval application. So this is the basic flow. So once the user logs in, say in your company you have a couple of people who want to apply for a leave, right? And then you are going to have some kind of internal portal where the users can log in. And once they log in, it redirects them to the home page where it shows that you can request a leave, or it shows the current status, like how many leaves you have applied and those sort of information. And then once you request a leave, we have two flows. So once you request leave, and if it's say less than 2 days, it gets auto approved. So that could be something like a sick leave or anything like that, because generally less than 2 days is still acceptable, right? But if it's something more than that, say it's for a vacation or it's for a some kind of event that the person is going to, then probably you would require the manager's approval or somebody else's approval, right? So in that case, we're going to send a request to the admin, and the process is going to wait until a person manually is going to approve that leave. So this is with respect to the user. Now coming to the admin or the manager, right? So the admin also is going to have an internal login portal where he's going to log in. And after logging in, again, is going to show information on what is the current statistics. And after that, he'll also be able to see the requests that have been put up by his fellow employees. Right. So once that is there, there's an option to approve the leave. And once he approves the leave, the respective person will be notified. So for the entire application, we are going to use the serverless components and see how the flow would be working and what all the services involved in each step, and how we are going to deploy them. Right. With that, let me show you the demo of the application that we are going to build. So this is the home screen, and you need to log into the portal. Yeah, once you log in, you can see the number of the previous request and the total number of requests done, and you can see that the current request is done. And let's say we request for a leave. Say 2 days, just having fever. So anything 2 days and below that, it's going to auto approve. So you can see the new request that has been approved over here, right? But let's say we're requesting for something higher than that. Say you want to go for a vacation. Right, you can see that the pending request has been updated, and here you can see that the user has requested for it, and then you have an option to either approve it, approve or deny it. So here in this case, let's approve the request. So once the request has been approved, the system will be updated, and here you can see in the updated request that the status is manual, meaning one of the admins has approve the request manually, and the timestamps and information like that. So this is the application that we are going to build, and we'll see into what all the items, what all the services that we're going to leverage to build the application. Now, coming to the application, right? So we're going to use S3 buckets where we are going to deploy the application. So the front-end side of the application. So all the media files and the React application that we're going to use, we're going to use S3, which is a storage service, which can also be used for hosting the website. So we're going to host the website over there, and then we're going to use Cloudfront to distribute it to the end users. Now, why Cloudfront is required? So Cloudfront is Amazon's CDN network. So what it means is that let's say we're going to deploy the website in Mumbai region, right? And we have users from Bangalore who are going to access the website. And let's say Amazon has the concept of edge locations, and let's say that Bangalore is one of the edge locations. So when the user is going to access the website, so the first request is going to hit the Mumbai servers, the Mumbai S3, and you're going the files will be fetched from there. So what Cloudfront does is that it's going to cache the content into the user's nearest location. So let's say if Bangalore has an edge location, Cloudfront is going to cache those files in the Bangalore region. Now, what's the advantage of doing that? So the first user is going to get the request from the Mumbai region, right? But any other user after that, so the second, third, and the corresponding users are going to fetch the files directly from the edge location, which is from the Bangalore region itself. So the request will not go until Mumbai and come back. So this is one of the advantages of using Cloudfront, that it provides this caching mechanisms, and Amazon Cloudfront has edge locations spread throughout the globe. So it can drastically improve your website performance and how users are able to fetch the information and things like that. So that is with regards to the website. Now coming to the actual application flow, right? So you have a user and you are going to have a login page. And for the login, which is basically for the authentication, we are going to use a service called Amazon Cognito. So using Cognito, we're going to leverage the sign in and sign up pages that Cognito provides, and Cognito also provides the access keys and tokens. So we're going to use that to maintain the user session and get information about which user is logging in, what is his mail ID, and based on that we need to get the user information, right? So that is the for that reason we're going to use Cognito. So in Cognito, we're going to create a user pool, and in that we're going to, like, our users are going to sign in, and from there we're going to take it forward, right? And then we have a sign up trigger. So in Cognito, you have the capability to configure triggers. So using that, we're going to configure a sign up trigger, which is so as soon as a new user signs up to the portal, it's going to create some metadata for the user. That this user is signing up for the first time, so just some basic metadata that we are going to create, right? And then we're going to build 3 APIs. So we're going to have 3 APIs in the application. So after you log in, it redirects to your home page, and from there, the first API that gets called is going to get the user information. Right, so all the user information is stored in user info database, and for the temporary leaves, like the leaf that needs to be approved, we're going to use another table that's going to store that temporary information. So once the user logs into the system, is going to trigger this API and get the API. It's going to hit the API gateway. API gateway is again configured to trigger Lambda. So Lambda is the compute service that is available. That's the serverless compute service that is available. So using API gateway, you can integrate to a lot of other AWS services. So in our use case, we are going to integrate it to a Lambda and a step function. We'll get to step function in a bit, but yeah. So the first flow is that once the user logs in, is going to get the user information. So the Lambda is going to perform the get operation on the database and send that information back to API gateway. The second API is to apply the leave. So in this, we're going to call a step function. So this is where the choice statement happens. So basically, step function is a service that is used to orchestrate multiple AWS services together. And apart from being able to orchestrate services, you also have step function also has some inbuilt logic functions that you can leverage. So one of them is choice. So similarly, you have wait, you have parallel states, you have dynamic parallel states, all of which can be leveraged based on the application flow. Right. So in our case, we're just going to use a choice statement, and if it's less than 2 days, it's going to call this Lambda, and it's going to update the information database. And in the other case, where it's more than 2 days, it needs to wait for approval. So it will hit this Lambda, and this wait for approval Lambda is going to update the temporary database. right? And then once the Lambda receives a success statement, then finally it's updated in the database. And then the final API, that is going to be the admin API. So here is going to approve the leave request that has been sent by the user. So this is with respect to the flow of the application. So what we're going to do now, so we're going to have a couple of sections. So in the first section, we'll see how to create a CRUD operation. So we're going to create a DynamoDB and Lambda and Iem permissions for the Lambda to be able to access DynamoDB and see how fetching an item works. Right. In the second section, we're going to integrate that to an API gateway, and we're going to see how to build a step function and some of the logics around that. And then we're going to create a Cognito user pool and see how the hosted UI is going to work. And then in the next section, we're going to deploy a simple website into S3 and see how we'll be able to access that. And at the end of it, we'll also create a Cloudfront distribution for that S3. After that, we'll deploy we'll clone the repo that has been provided and then deploy the application in the AWS account. So that's going to deploy the entire application with all the AWS services and the website that I just showed some time back. Then we're going to see how SAM and CloudFormation help us to do that, and what are all the commands and what is the syntaxes for using these two items. And after everything, we're going to clean up all the services that we have deployed just to make sure the system is clean. Right. So moving to the first section. So I hope everybody has their AWS account open. All right. And also make sure that you have the repo handy. So in the repo, we have a getting started folder. So this is going to have some of the codes that we're going to use at this point to see how the CRUD operation works and things like that. So make sure you have it handy to copy some of the codes. And in case you're not like you missed some step, you can probably look at one of these videos, and that's going to have the flow on creating that specific service. All right. Open your AWS console and let's start with DynamoDB. So search for DynamoDB in the services tab, and make sure you open it in a new tab because we'll be switching between different services at this point, and it would be better if we have some of the services open. Yes. So this is the basic DynamoDB dashboard that you're going to see as soon as you log in. So on the left side, click on tables. So here you can see some of the tables that is already deployed. So for this section, we're going to create a table. So on the right side top, you'll be seeing the create table button. Click on that and provide the table name as demo at this point. And so coming to the partition key and the sort key. So DynamoDB is basically a NoSQL database, and it's a fully managed service by AWS. So the way you access a DynamoDB table is by providing the primary key, right? So you store JSON-like objects in DynamoDB, and you provide one of them as the primary keys. And by giving the primary key, you'll be able to fetch that entire JSON document. And apart from primary key, you also have the option to provide a sort key. So you can use this in combination to fetch items. So in our case, let's just use the primary key and provide email. And once you provide that, you will also be able to select the type of key that you're looking at. So in our case, it's a string. And scroll down to the settings section. So click on customize settings. Right. So once you click on customize settings, you'll be able to see the read-write capacity units. So coming to the read-write capacity, so DynamoDB is basically charged on two different items. One is the amount of storage you're going to have, like the total storage of DynamoDB and all the records you have in it. And the other one is the amount of reads and writes you're going to perform on the system. Now, when you keep it to provision, so you're going to set a minimum and maximum capacity number, and anything beyond that, the system will wait until the existing read operations is complete. So in provision, you have control over like what is the minimum and maximum capacity, right? But on the other side, you have an on-demand. So on-demand is basically when you're letting AWS control the read and write, the number of read and writes to be performed. So let's say you have a couple of users, and in that case, the read write capacity needs to be low, and suddenly you have an inflow of traffic. So you need to have a larger read write capacity. So when you keep it to on-demand, the DynamoDB will automatically scale up the number of read and write that it needs to have to satisfy the new spike in the load, right? But when you keep it to provision, you have a maximum cap that you have set, and after that, your read and write request will be a little slower compared to the on-demand version of it. Now, when you keep it to provision, it's kind of like a fixed billing that you're allocating that say for 10 units. 10 units must be there in the system, irrespective of how much you're going to use in them or not. But on-demand, it's highly flexible, and based on how much you're going to use, it's going to be billed. So in our case, let's just keep it on demand because the number of read and writes we're going to perform is kind of very low, right? And then scroll down, and then you have the create table option. So once you create the table, it's going to create the table. So this will take a couple of seconds. Yeah. So you have the new table ready. And let's click on the table to see what are all the items. What is the information available? Right. So once you click on the table, you'll be seeing the general information, right? And then on the right side top, you'll be able to see view items. So click on view items. So because it's a new table, you're seeing that there are no items over here. Let's create an item and then fetch that, use that item, consume that item from the API. So when you scroll down on the right side, you'll be able to see create item. So click on that, and you'll either see You'll either see a form kind of screen or a JSON kind of screen. So on the right side, you can switch between those two depending on which is easier for you. So let's give the email as demo@123.com, right? And then let's just add a couple of other parameters. So date, let's add it as 23 and say month, October. So you can provide any information over here. So we'll be fetching the information from the table when we are creating the Lambda. So once you provide the JSON document,
sir,
click on.
Please repeat again on time, sir.
Sorry.
Sir, that DynamoDB setup, sir. Please repeat it again on time.
Just a minute. I'll just finish this creation item, then I'll repeat the same item. Okay. So once you provide the JSON document, just click on create item on the right side bottom. Yeah, coming to creating the DynamoDB. So in the DynamoDB screen on the left side, you'll find the tables section. So click on tables. So this will show you the existing tables that are there. And here on the right side, you have create table button. So click on that. Then provide the table name. Okay. And then provide the partition key as email. So partition key is the key that we are going to pass to get that JSON document that we just created. Okay. And then in settings, click on customize settings. And in the next section, which is the read-write capacity, click on demand. And then scroll down and create the table.
Thank you, sir.
Yeah. So once you create the table, click on the table, and on the right side top, you have view items. And over there, as you can see, this is the item that we just created. So you're able to see that information over here. So on the right side, again, you'll be able to see a create item. Click on create item and create the JSON document. Yeah, so that is with respect to creating the DynamoDB. So next we'll move on to creating a Lambda function.
Just one question, sorry.
Yeah.
Yeah, so would a free tier be enough for this entire demo?
Yeah, it will be more than enough. So
okay,
yeah, DynamoDB also, I think you have 25 GB of data storage as part of the free tier, and I think you also have a little bit of read-write capacity provision. And even if that's not the case, the number of like once we set it to on demand, that means you'll be charged only for the units you're consuming. So that will be a very less number. Like it'll be pretty much negligible. You might not even get it in the bill. That'll be solo, because say, after we deploy the application in probably a few minutes or in a couple of days, we're going to delete it, right? So, and there won't be much of operation on it also. And at the end of the session, yeah, sorry.
Sir, show the JSON file.
Okay. So just provide an email ID. It's just a dummy email ID. We're just going to use this information to fetch the item from database. And say date and month. So you'll either be seeing it in this format or you'll be seeing it in this format, in the form or in the JSON format. So here, if you want to do it, just click on add new attribute, say string, and string 1, value 1. And you'll be able to save the item. Yeah, so is everybody good with the creation of DynamoDB and adding an item to it? Like, all right. Okay, so we'll move on to the next service, which is Lambda. So from the management console, search for Lambda and open Lambda in a new tab.
You did.
And give a name to it and value. So you can give any key and value. Is just to have a JSON document so that we can fetch it later from the Lambda. So it doesn't have to be specifically the same item. It can be any. But only thing you need to make sure is whether you're giving email. So email is the primary key that we have given, which is basically the partition key. So that needs to be present when you're creating the JSON. Without that, you'll not be able to create a JSON. Okay, so moving on to Lambda. So once you open the Lambda console, on the left side, you'll be able to see the functions button section. So once you click on that, it'll show the existing functions and an option for you to create the function. So on the right side top, you can see the create function. So click on that. So just to kind of reiterate, Lambda is the compute service, the serverless compute service that is used for, like, any serverless application would ideally have a Lambda, because that's like the core of the serverless system. right? And coming to creation of Lambda, so provide a basic name. So let's just call it demo. And then in the runtime, you'll be able to see different options. So these are all the runtimes that is supported by Lambda. So for our case, we'll use Node 14.x, but you can feel free to experiment with the other runtimes later, right? So 14.x, and down you can see permissions and a button below that which says change default execution rule, right? So the item over here is that if any AWS service needs to access another AWS service, it needs to have permissions to do it. So we'll get into how to create them in the next section. So here you can just select the default option, which is create a new role. So what this is going to do is that it's going to create a new IAM role for this Lambda and attach it to this function. And in some time, we're going to see how we can how we'll be able to edit the Iem policy and how to give permissions and things like that. Okay, so just to kind of reiterate, so provide the function name as demo and select the node 14.x as the runtime, and the default execution role is the default selector option itself, right? And then on the right side bottom, click on create function. So this is the function screen that you'll be able to see. So on the first section, you have the overview. So
yeah, sorry to interrupt. Can you just give me an overview of what is a layer, Lambda layer, and what is a destination and trigger?
Yeah, I'm coming back. Yeah. So the first section over here is the function overview. So this is going to show what are the about the Lambda, like what is the ARN, what all the services that can trigger this Lambda, and what are all the say destinations or items that this Lambda is going to trigger as the next step, right? So once you connect an API gateway to it, you'll be able to see that as one of the triggers. So that basically means that API gateway is having permission to trigger this Lambda, right? So that is with respect to triggers. And then coming to layers. So layers is a separate entity of sort that you can attach to all the Lambda functions. So let's say, for example, you have some set of modules that you need to use across multiple Lambdas, right? So instead of installing them in each Lambda, what you can do is you can create a layer out of it and attach that layer to all the Lambda functions that you want to use it on. And then the other advantage of doing that is anytime there's an updation happening in that module that you need to change something, you can update the layers and automatically all the functions would be using that latest version. So layers also provides you a version control. So you can have different layers, different versions of the layers and use them appropriately. Similarly, you can also create Lambda's versions, and then you can use them based on the use case. And then on the right, yeah.
Hello, can you just guide me through the steps of the Lambda?
Yeah. Yeah. So
go on functions. Yeah.
Yeah. On the right side top, create function.
Yes.
And then select the default option, which is author from scratch, and provide the function name as say demo for us at this point. And then select the runtime as 14.x, like that's a defaultly selected option, and we're going to use that itself for the demo at this point. Okay. And then on the right side bottom, just click on create function.
Okay, thank you.
Yeah.
Change default execution role, nothing we have to do, right?
Nothing is required. So you can
Okay.
use the default setting, and we'll get that. I mean, we'll get to that later as to editing the IAM role and stuff.
Okay, thank you.
Yeah, and on the function overview on the right side, you can see if you have given any description to the Lambda. Like at this point, we just gave the Lambda name and last modifier and the function ARN. So basically, every
So
service.
Sandeep, what I understand is layer is kind of yeah, feature that is used for reusability, right? In case if
Yes.
I need to just connect the Lambda with one of the other AWS services, I can use this layers to connect with it. Is my understanding right?
No. So layers is very specific to Lambda functions. So layers is like a common module that you can use across, or common set of packages that you want to use across multiple Lambdas. So if you were to like, instead of installing all the modules and packages in each Lambda, what you can do is install all of them in this layer. And when you're creating the Lambda, you can just say use this layer. So that Lambda will have access to all those packages and modules.
So imagine I'm just using a Python library. So rather than me installing the library every time in a Lambda function, I can put it together as a package in layers and then reuse for each and every Lambda function.
Yes. Say one of the examples would be, say, you want to perform video transcoding, for example. So for that, let's say we're using a package like FFmpeg, right? So instead of installing FFmpeg in all the Lambdas that you're going to create, you can have you can create a layer out of it and attach that to every Lambda that you create. So the advantage we get is, say, suppose we want to update or make some changes in the FFmpeg module. We don't have to edit all the Lambdas code, right? We just have to edit the layer code, and once you update it, all the functions will be fetching the latest information.
Got it. Yeah. Thank you.
Yeah. And on the right side, you have basic information like description, last modifier, and function ARN. So basically, every service in AWS is going to have an ARN which is unique. So ARN basically stands for Amazon Resource Number. So in all the you'll be needing this ARN when you want to connect it to other AWS services, or you want to refer to that, and things like, or you want to perform any CLI based operations on it. So in those cases, you'll be using the ARN. It's basically a unique identifier for every AWS service that you create. Okay. And coming to the next section, we have the code. So this is an online editor that is available. Like, you can use this to edit Lambda functions and create, like perform basic operations on it. But in an ideal scenario, or let's say on a day-to-day development basis, it is preferred to not do it from the console and to do it via the code base or via GitHub, and then connecting that to the pipeline and things like that. But for our use case, let's just see how the code works, and what are all the parameters, what should be the output, and the files and things like that, right? So the basic structure of Lambda is going to have an index.js file, and that's going to have the main function, which is exports.handler, right? And the name of the function is important because you're going to tag that to your runtime settings. Okay. In runtime settings, you mentioned the runtime or the code version that you want, right? And then you also create the handler item. So handler item will basically tell that when this Lambda is invoked, what file and what is the first function that it needs to invoke inside that, right? So when you create a Lambda, the default item and default file that gets created is index.js, and you're going to have this handler function. Okay. And then you have an event as the input. So when the Lambda is invoked, you will get the input data in the event item. Okay. I'm just going to print the event item to show you how it works. Okay. And when you make any changes, on the right side top, you have a deploy button. And let's just test the basic event to see what response we get. So on the test click on configure test event. Like since the first time, you'll have to create a test event and give the test name as say demo, and we can just keep the basic JSON itself, right? And then on the right side bottom, create. And once you have created, let's say you want to test it. So the test button over here, once you click on it, is going to take the default demo. And here you can see the response, right? So this is the response that we have configured in the index.js. Okay. And then the function logs. So basically, almost all the services in AWS are going to create logs, like any like that's like the basic logic of every application to have logs, right? So Lambda is also going to create logs, and AWS uses a service called CloudWatch, which is like the place where all the logs are going to be stored. Okay. And this is how Lambda generates the logs. So you have a start event, you have an end event, and a report, and anything that you log in between will also be stored over here. So we just log the event, right? So this is the event, key 1, key 2, key 3 that we just passed. So we're seeing the result for it. And then coming to Lambda. So Lambda is basically built per millisecond of execution, right? So here you can see that in the report, you can see the duration, right? So duration is say 26.9 millisecond, and you're built for every millisecond. So it's rounded up to 27. Yes, somebody wanted to talk.
Hello. Regarding the test event, I clicked on this in configure test event. It's asking me event name. What should I do?
Yeah, you can just provide demo as the event name. That should be fine.
Okay. And then
on the
key 1 value, leave it as it is. Key 1 value, key 2 value.
Yeah, you can leave it as
and create.
Yep.
Okay, thank you.
Yeah.
And hello. For the logs, where do I go?
Sorry?
To see the logs.
Yeah. So
where do I go?
once you save the test event, click on test.
Yeah, I've got it.
Yes.
Thank you.
So this is basically the execution result of the one that it is created.
Yeah, I got it.
I just had one question here, Sandeep. So the default ARN that you attached to the Lambda, that already has this permission to interact with CloudWatch?
Yes.
Okay, thank you.
And I will show that in a bit. But yes, that's a valid question. Yeah. So when you create it through the console, when you create the Lambda function through the console, it will add the default log permission. So Lambda also needs permission to access CloudWatch to create the log stream and put the logs over there, right? So for that, it needs an Iem policy, which is going to say like, this Lambda is going to create this log stream and put the information over there. So that policy is added by default when you're doing it from the console. So we'll just go there in a bit. Right. So coming to duration, like I said, Lambda is built per millisecond. So you can see the build duration over here. And then on the next side, you have something called as memory. So Lambda is charged based on two things. One is your memory size and how much duration it runs. So as your memory size increases, the cost of it also would increase. And similarly, as the duration increases, the cost will increase. Now, the trick over here is that when you increase your memory, let's say right now it's at 128. If you say run it at 256, your runtime would decrease. Like the higher the memory, the faster your Lambda will execute. That will work until a certain point. Like if you're continuously increasing memory, after one point, even though you increase your memory, your runtime will be less. The difference in your runtime will be very less. So there's like a fine balance between how much memory you need to set to get the proper cost optimization. So this concept is called as power tuning. So you can look it up and you'll get the entire information on how the memory size is going to affect your Lambda run duration, and what will be your optimal point where you get the highest benefits out of setting the proper memory, right? So coming to the logs, so on the top you have the monitor section, Okay. So once you click on the monitor section, you will get the default CloudWatch. Sorry.
Sandeep? Yeah, Atul here. So there is an instruction from the organizers that if participants have a question, please use the chat box to ask your questions. Don't interrupt the speaker. We will try to resolve your questions over chat window. If needed, we will have a timeline separately for one-on-one. And anyhow, the speaker is
Can't
going
we
to
mute everyone?
the...
Can't we mute everyone?
Yeah.
In that case, please.
Let me complete. Yeah, the speaker anyhow is going to repeat the steps at least twice. So please try to follow him. Yeah. And use chat box for the any queries. Thank you.
Thanks, Atul. Yeah. So yeah, coming back to the Lambda. So on the top, you can see code, test, monitor, configuration, and these items, right? So when you click on monitor, you'll be able to see the CloudWatch metrics and CloudWatch logs. Right? So in the metrics, you can see the basic graphs that is defaultly populated by CloudWatch, like the invocations, the run duration, the error content, things like that. So this button, say view logs in CloudWatch, that is going to redirect you to the exact log group for this Lambda. So here you can see the recent invocation that we did. Okay, so this is the log stream that it has generated. So when you click on that, you'll be able to see the logs. So we had 2 executions, and the billing and all that information you'll be able to see over here. Okay. Now coming back to the code. So what we're going to do now is we're going to try and fetch information from the database. The item that we just created will try to get that information. So in the repo, in the getting started folder, you have lambda.js file. Open that and just copy the code. So in the repo, getting started, in that lambda.js file. And come back to your Lambda console and just replace the entire section. Okay. And then deploy the changes. So now that we have added the code, so what this is going to be, do is that we're just declaring that take the we're declaring a variable called email that is going to come as part of the event, and we're going to call a function that is going to connect to the database, which is basically demo table in our case, and get the information. So it's going to do a get operation and get that item from the database. And now when you test it, this is going to fail, because your Lambda needs permission to access the Dynamodb table. So here you can see, so anytime there's a role error that is going to occur, so in the logs, you'll be able to see clearly that what is the errand that is trying to perform which operation on which resource. So here you can see that this role is trying to access Dynamodb get item on this table. This is the table error, and that is failing. So to fix this issue, we need to add the permission in the Iem policy. So Iem is the service that we are going to use for any kind of service-to-service access that we want to provide. So on the top section where we have code, test, monitor, so click on configuration. So once you click on configuration, on the left side, you have permissions as the third item. So click on permissions, then you'll be able to see the role item, right? So when you click on this hyperlink, it's going to redirect you to the role that has been assigned to the Lambda. right? So configuration, and then on the left side permissions, and then click on the role name. Yeah, and make sure you have your make sure you have the GitHub repository open. So some of the codes will be taking from there to replace in the actual function. So make sure you have it open and copy that specific code that which we are talking about. Okay. So once you click on the role name, it's going to open a new tab, which is the IAM console, and it is going to open the exact role. Okay. So coming to permissions, right? So like I just said before, that if you want to access any other AWS service, so from one service, if you want to access any other AWS service, you need to have a permission attached to it. If that permission is not there, you're going to get an error telling access denied. Okay, so in our case, the first example that I'm showing is the exact error. So in this Lambda, we're trying to access the database. So we're declaring DynamoDB client, and then we are declaring which table it needs to use, and we're performing a get operation. So when we try to do that, we'll get an access denied error. And in that error message, you'll see what is the role that is trying to perform the operation, right? And then here you can see that this role is not authorized to perform this operation, which is DynamoDB's get item on this ARN. Yeah, so this is how you come to know that it's an permission issue. And when you read that error, you'll also be able to identify what is the exact issue. Okay, so coming back to permissions, click on configuration, and on the left side permissions, open the IAM role. Right. Now coming to the IAM role, so this is the role that was created when you clicked on that create function. The role that I said is going to get automatically created. So this is the role. Right. And then now you have to add a policy that will say that this Lambda can access this DynamoDB and perform a get operation on it. Okay. Click on add inline policy. So there are different ways of attaching the policy. You can either attach one of the policies that is readily available by AWS. So there are like predefined policies like DynamoDB full access or anything like that. So you can either attach those roles, those policies, or you can create a new inline policy. So inline policy will be specific only to this role. Like you cannot reuse it. But if you are creating a policy separately, then you can reuse it across different roles. So in our case, we'll just be creating an inline policy, and I'll show you how it works. So scroll down to permission policies. On the left side, you have attach policies, and on the right side, you have add inline policy. So click on the add inline policy. Yeah. So this will take you to the policy visual editor. Okay. And then here you can choose the service. So in our case, we want to provide access to DynamoDB. So once you type in the search bar, you'll be able to get that item. Click on DynamoDB. And then it's going to show you the actions that you can perform under it. So in this case, we want to perform a get item operation. Okay, so click on the get item. And in the resources, we're going to specify the ARN of the table. So you can either copy paste the ARN over here, or you can just create it. So I'm using Mumbai region. So, or you can give a wildcard. So any one of them works. Okay. And then you provide the table name. In our case, it is the table name is demo or any other name that you have specified. Okay, click on add. Okay, so now you are given permission for the service DynamoDB for the action get item and the ARN you have provided. So this is the visual editor way of seeing it, but in case you want to see the actual JSON version of it, this is how it's going to look. So on the top, right next to visual editor, there's a JSON. So you can either use the visual editor to create, or you can copy paste the JSON that you have, right? And then on the right side bottom, review policy, and give a name for it, say demo DDB. Okay, and then create policy. Okay, so now you have the policy attached to this role. Now we'll go back and run the Lambda and see if there's an issue. Okay, so ARN is basically, say DynamoDB, you select the service, you select the action, and then specify the ARN, right? So here in ARN, you can say any, and then provide the table name that you just created. You can either do it like this, or you can just say all resources, which is going to give a star, which is going to add a wildcard to it, and then review policy, provide the name, and then create the policy. Okay, and that is also available as part of the repo. So in the repo, in getting started, you have the file called iem.json. So you can copy paste this code and change the region and these three items. Change the region, account ID, and the table name. This is in case you are getting stuck on how to create it from the, like if in case you are not able to follow, you can just copy paste that code and change the region, ARN, and the account number. Okay. So coming back to Lambda, click on the code again. And just a reminder that every time you make any changes to the Lambda code, you need to deploy the changes for it to take effect. Any small change that you're doing in the Lambda, you need to deploy the code. Okay. So now that we have added the IAM permission, now when we test this, it should not throw us a permission issue error. So let's configure the test case first. Okay, so click on configure test case and provide the key as email. Okay, and then the value should be the one, the item that you just created in the table. So I have created demo@123. So similar to that, the item that you created in the demo table, take the email of it and provide that as the value. Okay, so once you do that, click on save. And now when you test it again, it should work. Yep. Yeah, so just to kind of reiterate, click on configure test event, give the key as email, and the value for it is the new item that you created in the table. So in my case, it is demo@123. Okay, provide the value over here, save the test case, and then click on test. So when you do that, you'll see the response status 200, and in the body, you can see the item that we created in the database. Any doubts, or is anybody having an issue? All right. Yeah, just a second. Yeah. So now we have created the DynamoDB, and then we have created the Lambda. We have added the corresponding Iem policy to it, and we just performed a get operation on the database. So this is with the first checkpoint, right? So we created the table, the Lambda, the Iem permission to it, and we saw how to create the policy and make sure Lambda has permission to access DynamoDB. And then from the Lambda, we call the get item and fetch the item. So in the next section, we're going to see how to create the API gateway, the step functions, and the Cognito. So let's just take 1 or 2 minutes to make sure that everybody has reached this checkpoint. Okay. So moving on to the next item. Oh, looks like there is an issue. Just a second. Permission issue will. Okay, so let me kind of reiterate what we did there. So in the repo, under getting started folder, you have lambda.js. Right? So open lambda.js, copy that code either by clicking here or copying the entire item. Okay, then go to your Lambda function and paste it. So once you paste it, you need to click deploy. Okay, after that is done, you need to add the Iem policy to it. So for that, scroll top. Here you can see code, test, and monitor. So this section on top, that navigation bar, there you click on configuration, right? And then on the left side, you have permissions, which is the third item. So over there, click on the role name. And then here you have add inline policy. Right. So click on add inline policy and then select DynamoDB. Okay. And then the action that we want to perform is a get operation. So click on get item. And then in the next part in resources, we provide the ARN. So as in the ARN, you provide the region as any, and table name is the name of the table that we just created a couple of minutes back. Okay, click on add. So now you have the permission ready. Click on review policy at the right bottom corner, and then provide the name. Okay, once you do that, you'll be able to create the policy on the right side bottom and create it. So once you create it, it'll redirect you back to the role page, and here you'll be able to see the roles in policies that you have created. And this is the basic Lambda execution role that gets created when you create the console. I mean, when you create the Lambda from the console, and that is going to have your log permissions. So this is the one that we just discussed some time back. Right. So after that, go back to your Lambda, go to code, and then configure the test event. provide the key as email, and paste the value that you have just created in the DynamoDB. And then run it. So when you test this, you should be able to get the item. Okay. So that is with respect to wrapping up the first section. So now we'll go to the second section, which is creating the API gateway and integrating the Lambda that we just created. Right. So you can close these tabs and then go to the management console, search for API, and then open that in a new tab. Okay. So when you're starting for the first time, like you might get a different home screen. So in that home screen, you're going to have like 4 options. I think it's HTTP API, REST API, REST API private, and WebSocket, right? So in that, you need to select the REST API. So so just to give a gist about what these 4 variants are. So REST API is the full-fledged API with all the options enabled. Say one of the options or one of the features you can do as part of that is like usage plans, and those kinds of functionalities you can do in the REST API. So that's basically the full-fledged version of it. And then HTTP API has some of the features removed, but the advantage is that you get a better cost saving while using the HTTP API. And then with respect to WebSocket API, anytime you want to use a real-time connection, like say a chat application or any analytics dashboard where you need to populate the data in real time. So in any of those places where real-time interaction is required, you can use a WebSocket. So using a WebSocket is going to make the connection to the server. And then as long as the user is connected to that API gateway's WebSocket, you can send or receive messages to it. Okay. So the last option, which is the REST API private, is when you want to use an API only within the VPC. So VPC is the private cloud that you create in the Lambda. I mean, in your AWS console. In case you want to have a private API which is not exposed to the internet, you can use REST API private. Okay, so click on the create item for REST API. Yeah, so here you have a build option. Click on the build. Okay, so this will take you to the API creation website. So in choose the protocol, you have REST or WebSocket. Click on REST, and in the next section, so you can either create an API in the console, or you can import it from a Swagger file or an open API definition, or you can clone it from one of the existing APIs. So in our case, we're going to create a new API. So let's just leave the selected option and say give the API name as demo. Okay, and then create API. Okay, so once you create that, it's going to take you to the API's homepage. So on top, you can see the API information. So this is the API that was created, and we are currently in the resources section, right? So now, once the API is created, you need to create the underlying paths and connect them to your AWS services, right? So let's create, since we are doing a get operation, let's create one resource to do that operation. Okay, so under actions, which is right next to resources, click on create resource. So once you do that, it's going to populate the new child resource section. Okay, it's going to ask for resource type. So let's name it as get data. So since we're just getting some simple item from the database. Okay, and then the next item, enable API gateway calls. So check that box. So you need to enable CORS anytime you're doing a cross-domain access. So in our case, we'll be directly fetching it from our local system. So that's why we're going to enable the CORS. So enable the CORS, and on the right side, click on Create Resource. Okay. So after you do that, you'll be able to see /get data. Okay. And then again, under the actions, click on create method. Okay. So under the create method, you have get. So these are all the options that are available. But in our case, since we are just getting a simple item from the database, we're going to perform a get operation on it. So click on get, and then tick the checkbox right next to it, and that is going to create it and show you the options. Okay. Now, this is your setup for get. So this is where you configure that when you call /getData API with a get request, with a get type of get method of request, what it should do, like what AWS service it should invoke and perform the operation. So this is where you integrate API gateway to an AWS service, right? So in our case, we're going to integrate it with a Lambda function. So leave the default as it is, integration Lambda function, and then use Lambda proxy integration. So check this box. So this is basically done so that you get the entire API information to the Lambda. So when you enable proxy integration, you'll get all the API parameters also, like the parameters that is passed to the URL, and who is the requester. So these kinds of information, like the entire set of information, you will get to Lambda when you're using a proxy integration. The other part of using the proxy integration is that you need to send the success code and the body in the defined way from your Lambda itself. Okay. So select region is AP Southern, like I'm currently in Southern, and you can select the respective resource. Okay, in the Lambda function, you can type in the name of the resource that you just, the Lambda function that we just created. So we created demo. So once you start typing it, it should auto-populate the resource. Okay, click on that. And then on the right side, you have save. So save it. So once you click on save, it's going to show you a pop-up, which is going to say add permission to Lambda function. So now that you're doing it from the console, AWS will automatically create a role, attach it to API gateway, and add this Lambda in the permission list. But if you're doing it, say, in the CLI or in the programmatic way, then you'll have to do it yourself. So once you click on OK, it's going to create the roles and permissions required for you to be able to do this. Okay, click on OK. Right. So once you do that, when you turn it, when you click on get, you'll be able to see the method request, the ARN of it, and here in integration request, you can see Lambda proxy, and here you can see the Lambda name on the right side corner. You can see the Lambda name that was created. Now, you have we have created the resource path, right? But now we need to deploy it to get the final URL, that the API URL that we'll be using, say, in the front end or any other application to consume it, right? So to do that, click on the root, and the main / the home path. Click on actions and say deploy API. So when you click on deploy API, it's going to ask you for the stage options. So since this is the first time, we're creating the stage, you need to select new stage. So stage is basically used for any kind of canary deployments. So what it means is that you can have two stages, like say prod and dev, and you can configure both of them on two different Lambdas. So let's say on the dev, you associate the Lambda that you want to test or any other newer version of the Lambda that's still under testing. And you can use that URL to perform all your testing and stuff. And once that has passed, you can update the prod version also, prod stage also with the latest Lambda version. So we'll just give the name as prod, stage name, and then say deploy on the right side. Right. So after you have deployed, you'll be able to see the next screen, which is on the left side. You can see that it has moved to stages. So on the stage name that you just created, expand that, and you'll be getting /getData/get. Okay, so when you click on this, you'll get the final API URL that you need to invoke to call the Lambda function. Okay. So when you click on this, open it in a new tab, and at this point you can see that you are getting a internal server error message. So this is because when you have enabled proxy integration, the way you get the data would be different. Like so you need to handle that in your Lambda function. So let's go to the Lambda function. Okay, so let's create the API gateway again. I think some of us are having issues. Okay, so go to the API gateway console, and on the right side, create API. So I'm just reiterating the creation of API part. Okay, and then REST API, click on build. So here you select the protocol as REST and say new API in the second section and give a name to it. Okay, and then on the right side bottom you have create API. So once you create API, it's going to take you to the API's homepage, the newly created API's homepage, the resources tab. Okay, and then click on actions and create a resource. So this is the path that you'll be using to access the Lambda function, basically. Okay, in the resource name, give it as get data. And then click on enable CORS. So CORS must be enabled for any kind of cross origin access, which is basically like, say from a different domain, when you're trying to access, you need to enable CORS. Then click on create resource. So once you do that, you'll be able to see /getData under resources section. So while you have selected get data, click on actions and say create method. So in our case, we're using a get method, but feel free to experiment with the other methods. Okay. So once you click say get and click the checkbox, click the tick mark, is going to open the setup for that guest. Okay. And then here you can see the integration type by default is Lambda. So that's the one that we're going to use. You can also connect to any other AWS service if required. And then check the proxy integration, because we'll be sending the data from query parameters. And if that needs to be passed to Lambda, you need to enable proxy integration. Otherwise, only the body section of the API will be passed to Lambda. And then in the Lambda function, you can start typing your Lambda name, which is demo, and it will populate automatically when the Lambda is created. Okay. And then on the right side, after you select the appropriate Lambda function, click on save. And then it's going to ask you whether you need to give permissions for this. So this is basically to make sure that your API gateway has permission to invoke the Lambda function. Click on OK. And then you'll be able to see the home screen where it shows all the configuration. Here you can also see the type of integration that is there and what will be the ideal response. Okay. Now click on the root and say deploy API. Again, click on actions, click on deploy API. So here you need to provide a stage name. A stage name is basically used for the canary deployments. So let's just say prod as the stage name at this point, and then deploy API. So once you do that, you'll be redirected to the stages section. So on the left side, when you click on stages, this is the screen that is going to appear. And on the right side, you can see the invoke URL. So what it provides over here is the generic URL. And since we have a specific path, expand the stage and click on get, and you'll be able to see the actual path that is there. So this is the URL that you'll be configuring in your front end or anywhere that you're going to consume this API. So this is the URL that you'll be using to do it. And when you invoke that URL, you're going to have a error. This is because the Lambda, what we tested is getting data directly from the event. But now since it's going to get data in the proxy format, there are some changes we need to do to the Lambda. So go to the Lambda, the demo Lambda that we just created, and comment line number 21, which says let email equal to event.email, and uncomment line number 24. So comment line number 21 and uncomment line number 24. So here you can see in line number 24, it says email equal to event of query string parameters dot email. Right. So when you configure it as a proxy resource, you will get a lot of API information. So now that we are doing a GET request, we are going to send the data, which is the email, in a query parameter, right? So to access that, this is the change that you need to do in the Lambda. So once you do this, so just to reiterate, comment line number 21 and uncomment line number 24. And then click on deploy. Okay. Now the API link that just got generated. So there you can provide the email. So give a question mark and then email equal to the item name that you created. So from this stage, the URL that you get is going to, at the end, is going to have /prod/get data. So after that, give a question mark and then email equal to the ID, the DynamoDB item name that you just created. Once you do that, you will get the information. So again, going back to the Lambda, comment line number 21, which is email equal to event.email, and uncomment line number 24, and then deploy it. Yeah, so when you create the API gateway, make sure that you're selecting the type as get. Okay, and then when you invoke the URL from the browser, provide the email, provide the query parameter, which is basically after the URL, give a question mark, and then email equal to the item that you just created in the database. And when you run that, you're going to get the item that you have. You're going to get the item that you have created in the database. One second. So if you're using, say, Firefox or something, the way this is represented will be different, but you would still be able to get it. Yes. So remember that before calling this URL that is generated, make sure you edit the Lambda code. In the Lambda code, we are using comment line number 21 and uncomment line number 24. So if you see in that line number 24, you'll see that we are trying to fetch information from query string parameters. So this is the line that we'll be using to get the data. So comment the previously created line and then uncomment the line number 24, which is under Lambda proxy testing comment. So once you do that and deploy, then you'll be able to get the information. So I think many of us are getting missing authentication, right? So one of the reasons could be that you have configured a different type of request, okay? And the other part is in stages, in prod, the URL that you're getting, this is not the final URL. So after this, you need to go click on the get data, okay? And then click on get. So the link that you see over here, so if you see the difference, in the main part, you get only until prod. In the get data API, you'll get until /get data. So this is the API that you need to call. Call this API, and still you will get an internal error because you are not passing any parameters and the Lambda is failing. Then you provide email equal to the item that you just created. So that way you will be getting the information from the table. Yeah. So were you guys able to get the information in this format? Is there anything that we need to like repeat, or are we good to go forward? So to the people who are getting cannot read undefined property. So you're getting cannot read undefined property because you're trying to read from, because you have not changed the Lambda, the Lambda code. So go to the Lambda code, comment line number 21 and uncomment line number 24. So if you don't do that, you will still get an undefined error message. After you do that, click on deploy and then call the API with the URL parameter. So here the parameter is email. So and then the value is the item that you just created in the database. And when you run that, you'll be getting the response. Okay. Just to run it from the deploy API again. So once you create the get, okay, and then click on the root and say deploy API, select the appropriate stage. Now that we have already deployed the stage, it's going to show the existing one, okay, and then click on deploy. The URL that you're seeing over here is the URL for the root of the API, but we created one more resource called get data, right? So on the left side, which is on the second section, expand prod, then you'll be getting get data. Okay, in that, when you click on get, you'll get the final API. So this is the API that you need to invoke to call the Lambda. Okay. And when you call the API, provide the parameter, which is email equal to Dynamodb 123. Okay, so in the resources, once you have created this part. So in the resources, when you've created this part, click on actions, you deploy API, then you select the stage. Here, you need to provide the name. So we have given it as prod, but if you're giving some other name to it, then the final URL is going to change. So basically in the URL anatomy, this is the API gateway's URL that has been generated. Okay. After that comes the stage name that is created. In our case, that is prod. After that comes the resource, which is get data. And after that, we are giving the URL parameter email equal to demo.123. So this is how the URL structure works. So in case you're changing the name from prod to anything else or get data to anything else, remember that these two places you'll have to change it. And the way to get that again is in the API gateway, click on stages on the left side. You will get the stage name that you have deployed, expand that, and you will get /get data / the actual item. Okay, so when you click on the final get, you will get the API link that is going to call the get data API, which is connected to the Lambda that we just created. So we'll just take a couple of minutes over here to make sure that everybody is on the same page, and after that we'll move to the next section. Yeah, so to everybody who's getting undefined, it is because you have not updated the Lambda code. So let me show you over here again. So this is the previous code that we have copy pasted. And when you try to run this link, you will get the permission issue over here. Okay, I think some of you are trying to run it from the Lambda itself. So that is not where we need to test it after updating the code. So after updating the code, we are basically trying to invoke this Lambda from the API link, right? So go to the API gateway, go to stages, click on the newly deployed API, click on the path that you just created and get, then use that link in the browser. So when you click on that link, it's going to redirect you to this place, and here you need to provide the URL parameter. So this is how you need to test it after changing the Lambda code. So after changing the Lambda, just to reiterate, after changing the Lambda code, you'll not be testing it from the Lambda console. You'll be testing from the API link that is generated. Okay. Just to summarize everything that we did so far. So you can, after creating an API, you come to the resources section. Okay. In the resources section, you can create resources, which is basically going to define the path and it's also going to in that specific path you create a method. In our case, we're creating a get method, and you attach that to and you integrate that to any of the AWS services, right? So when you're doing that, you select we are selecting Lambda, but in theory you can attach any other AWS service. Okay, and in the root path you say create resource. So this is where you create the type of resource that you want to do. So just to kind of show again, so say get data to, and then enable course, create the resource. So once you do that, in that section, like when click on get data to or any other resource name that you just created, and then click on actions and say create method. Here, when you need to select, say, get or post or any other method, so let's say get in our case, then you will get the integration settings. So in our integration settings, we're selecting demo as the Lambda. Integration type is the same. Make sure you enable Lambda proxy integration, otherwise you'll not get the URL parameters in the query. And then save. And then it's going to give you a pop-up asking about Iem permissions. Say OK. All right. Once you do that, click on the API and say deploy API. So when you deploy API, it's going to ask for a stage name. In our case, let's use the prod stage that is already created, or else you can create a new stage. Then you deploy. After you deploy, it'll take you to the stages section. So in the stages section, you need to expand the stage that you just created, and then go to the link. When you click on the method, you will get the exact link or the API URL that you need to invoke to make sure that integration is working or not. So open that in a new tab. And the first thing you see is a server error because you're not passing any parameters, so Lambda doesn't know what to do. You provide email equal to, this is the ID that you just created in DynamoDB. And once you click enter, you'll get the information that we have stored in the database. So this way, you can make sure that, until now we have seen how to create DynamoDB, how to create a Lambda, how to create the IAM roles that is required for Lambda to access DynamoDB. And from the Lambda local event, we got the data from DynamoDB. And then we went on and created an API gateway, right? And we connected that API gateway to Lambda. So now when you invoke the URL that is generated, that is invoking the Lambda function, which is having the code to invoke the DynamoDB and get the information. That information, we are returning it back to API gateway, and that is what we are seeing over here. Right. And in case you're getting stuck anywhere and you're not able to follow, in the repo, again, as it's already mentioned in the chat, in the videos in getting started, there's a file called videos. So these are some of the sample videos showing how you can create that resource. So in case you missed any step, you can probably check out the video. And anyways, if that is, you can see the video and make sure whether you're doing it correctly. Okay. So moving on to the next service, so which is step function. So go to the console, search for step functions, and open that in a new tab. Okay. So before we start creating step function, so step function is a service that you use to orchestrate different AWS services together, right? And when you're creating a step function, you can have different kinds of flows attached to it. Say, for example, you want to call a Lambda and then say get some information from database, and then you want to send an email to somebody, and then you want to halt the execution until some manual process is taken, and say you want to wait for a couple of minutes and then call an API and wait for a couple of minutes again and retry that API in case there's a failure. So any kind of complicated logic or a business flow can be created by using step functions. So the two parts of it is, one of it you can tag any AWS service. So recently step functions announced the support for AWS SDK, which basically means you can create, you can tag it to, I mean, you can attach any AWS service or any AWS services API to it, right? And then the other side of it is the logical operations that the step function itself provides. So it could be a choice statement, it could be the wait statements, and state machine also provides the parallel paths and things like that. So now we are going to create a simple state machine, I mean simple step function, and I'll show you how the flow works and some of the choice statements and other things that we are going to use in the system. Okay, so go to the state machine console, and then on the right side you have create state machine. So click on that. Yeah, so here you have three different options. One is design your workflow visually and write the code and run a sample project. So step functions recently, I think a couple of months back, they announced the visual editor. So in case you're not knowing how to write the step function definition, what you can do is you can go to the visual editor and then use that, play around with that and identify drag and drop items. So it's basically a drag and drop console to create your entire step function workflow. Okay. And the next option is to write it in code. So when you do that, you can pass the state machine definition directly and use it operatically. And then the other option is run a sample project. So AWS provides a lot of sample projects that you can use to get started with and try to what is it? Like use one of these projects to get started with, right? So in our case, let's say write your workflow in code. Okay, so we're just gonna like copy. Yeah.
Sorry to interrupt, but we are halfway through, so maybe we can have a short break, maybe 5 minutes, 10 minutes break.
Yeah, I think this is a good point to take a break also. So yeah.
Because you are starting a new section, so you can take a short.
Yes, exactly. Yeah. So let's connect back at 11:20, 5 minutes from now.
It is 11:15 right now, everyone. Please take a few minutes of break and we can again join, and Sandeep will resume around 11:20, 5 minutes, 5-6 minutes from now. We all are here, so if you have anything, any other question, we are happy to answer. We'll start in a couple of minutes. Yes, Sandeep, you are good to start. Thank you.
Yep. Thank you. All right. So the next service we're going to cover is step functions, which is how to create a step function and look at some of the basic flows that are there inside it. So to give a summary again, step function is a service used to orchestrate different AWS services together. And with that, it also has the capability of some inbuilt logic functionalities like wait, choice statements, parallel states, and things like that. So go to the step functions console, and on the right side, click on create state machine. So here you have three options. You can either use the visual editor to create the step function, or you can paste the definition code directly, or run a sample project. We are going to paste the code directly because that'll be easier. But feel free to explore the visual workflow editor. So that's a beautiful UI which is having the drag and drop feature to kind of build the entire workflow. Okay, and then coming to type. So in type you have standard and express. So standard is used for large running tasks, and like a standard step function can run up to a year. Whereas on the Express, it is limited to 5 minutes. So an Express state machine cannot run for more than 5 minutes. But that also, the other part of it is the Express step function is much more cheaper compared to a standard step function. And like I said, the runtime reduces to a maximum of 5 minutes. So depending on your use case, you can choose either one of them. So in our case, we'll just use a standard. Okay. And coming to the definition. So for the definition, go to the repo, and in getting started, there's a file called stepfunction.json. Okay, so copy this entire code. So in the repo, in getting started, stepfunction.json. Copy that, go back to the step function console, and paste it in the definition section. Yeah. So as soon as you paste it, you will be seeing the error, which is basically pointing out to resource Lambda 1 error. So while creating this step function, if you're tagging or if you're orchestrating any AWS service, you need to provide the ARN of that service. So here I just used the placeholders for the resource, and that's why it's throwing an error. So for the resource, go back to your Lambda that you created, which is basically the Lambda name demo, and scroll to the top. In the function overview on the right side bottom, you have the function ARN. So copy that ARN. Okay, and go to the step function and replace in all the places that is showing an ARN error. Okay, so replace the entire thing, like the ARN should be inside codes. So this is how it's supposed to look like. Okay, similarly, scroll down and in place where in all the places where it's showing an error for the ARN, replace the ARN. So that's totally in 4 different places. So Lambda 1 ARN, Lambda 2, Lambda 3, and Lambda 4. So replace all the 4 ARNs. And once you have done it, your graph on the right side will look something like this. So it will change to show the actual flow of the step function that we're going to create. Okay, just to reiterate, go to the repo. Inside getting started, there's a file called stepfunction.json. Copy the content of that file, go back to the step function console, paste it in the definition section. And after you paste that, you need to replace all the ARNs. So there are totally 4 ARNs that you would have to replace. So once you replace all the ARNs, your graph will look something like this on the right side. Okay. Then you click next and provide a name for the state machine. So in our case, I'm just creating demo. Okay, and permissions. So again, even when step function needs to invoke any other service, it needs the IAM role and the permissions. So the similar logic, like how it works in a Lambda function, the same thing applies to a step function also. So here you can say create a new role. Then based on the definition that we are given, AWS will automatically create the role and add all the appropriate permissions to it. But again, if you're creating it from the CLI, you'll have to take care of all of this. Okay, and in logging, select all. Okay, and then scroll to the bottom and say create state machine. Okay, permissions. So in permissions, let the default option be selected, which is create new role. So just like how we added permission for a Lambda to be able to access DynamoDB, we also need to have add permissions so that the step function can access the Lambda function, the ARN that we just gave. So any ARN you are adding inside a step function, you need to make sure that the step function's role is having permissions to access it. Okay. And in logging, select all, and then scroll to the bottom and say create state machine. This will take a couple of seconds. Yeah. So the state machine is created. So the name is demo, and this is the home screen of the state machine. Right. So here, just to explain what we're doing inside the step function. So when you click on the definition, you'll be able to see the entire code on the left side, the definition code, and on the right side, you'll be able to see the flowchart that it was created. So what we're doing in this step function is we have a couple, I think, around 5 states, right? So first state is Lambda 1. So here, what we're saying is that we are given a type as task, which is basically to invoke any of the service. And then you have a resource where you're giving the Lambda ARN, right? So this means that for this step, invoke this Lambda, okay? And then in the next line, we're saying next is choice state. So after this Lambda is executed, what is the next thing that it has to do? So that you're giving by saying, by using the keyword next, and here we're saying it as choice state, which is the next step, okay? And then you also have something called as catch. So what we're doing here is using the catch statements, you can catch any error that happens in a Lambda or any other service you have configured over here, right? So here we're saying that for any kind of error, so error equals to states.all, which means for any kind of error, as soon as that error occurs, you call the fallback Lambda, which is configured in that next. Okay, so what this is going to do is anytime the Lambda fails because of any error, it could be code error or it could be an input error or whatever the scenario is, if a Lambda fails, it's going to call the fallback Lambda. Okay, so that is what we are using catch for. So apart from catch, you can also do something called as retrace. Like if you want to retrieve any specific service or any specific step for X number of items, X number of times, you can do that. Okay. Then we come into the choice state. So in the choice state, here the type is a choice compared to the last one, which is a task. Okay. So this is one of the logical operations that is there from step function. And here you have a keyword called choices. This is where you define the actual choice of the actual choice logic. So what we're doing here is we're saying variable $.foo. So when you say dollar, it refers to the entire input object. Okay, and you're saying .foo. So we're referring to the keyword called foo in the input. Okay, and now numeric equals 2. So if the number is equal to 2, then the next thing it has to do is call lambda 2. Okay, and in the next array you can see that if it's equal to 3, you call lambda 3. So basically from lambda 1, the data that you're providing should have a variable called foo, and if that is equal to 2, it should call the lambda 2. If it's equal to 3, it should call lambda 3. This is the logic that the choice statement is making. Okay, so apart from the choice, choice statement being number equals to, there are a lot of other complex workflows, or there are a lot of other complex choice statements that you can do using a step function. So here we're just covering the basic, which is a number or a string equal to something, and based on that you're calling the next item. Okay. Now again, lambda 2 is basically the same lambda function. So again, type is a task, and resource you have provided the ARN, and then you have a catch statement. And over here you have something called as end equal to true. So if the lambda function, or if this state or step is successfully executed, then it has to end the step function execution. Like that is the end of your entire workflow. So that's the logic. Similarly, for lambda 3, we are given the same. I'm sorry. So similarly, for lambda 3, we have given the same thing, which is end equal to true. So after that, we are also declaring the fallback lambda, which is going to capture any error when it happens. Okay. So on the right side graph, you can see the entire workflow that I just spoke about. So it starts with lambda 1. If there's a failure, it goes to fallback lambda, else it calls the choice statement. From the choice statement, it's going to call lambda 2 or lambda 3. And from there is going to call the fallback, from there is going to end the step function execution if it's successful, or is going to call the fallback lambda when there's a failure. Okay. Now coming to executing it. Okay. So on the top, you have a start execution. Click on start execution, and let's use the default input, because our function is kind of hard coded, so the input doesn't really matter over here. So just use the same input and say start execution. So at this point, your step function execution will fail, and we'll see how it's going to handle the process. So once you click on execute, it's going to show you the blue state, which is blue in step function is for anything that's in progress, green is successful, red is failed, and yellow is when there's an error. Right. So in this lambda, there is an error, and that's why it did not proceed to any other step, and it has gone to the fallback lambda. Okay. So when you click on that lambda 1, you'll be able to see what is the input, what is the output. And similarly, for any of the state that has been executed, when you click on it, you'll be able to see what is the input, what is the output, and if there was an exception, what was the exception. So here you can see the problem is that we have given the type as our lambda code is having the email property that we just declared, right? But we are not passing that as part of the input. So that is why the lambda is failing and you are getting this error. So let's go back to the lambda and make a little bit of change. So go back to the demo lambda. Okay. And comment line number 24 and the other return statement, like comment everything except for the last 2 lines, which is return foo 2. So you can see it in my screen, comment everything else and have only return foo 2 as in your lambda. Okay. And then deploy it. Now go back to the step function. and say scroll top to new execution. Again, the input doesn't matter because the output is kind of hard coded. So now when we run this, the Lambda is going to send output as foo2, right? And based on the choice, it should run the path it should take is Lambda2 and then end the execution. So let's see if that happens. So click on start execution. And it takes a couple of seconds before it is updated. So yeah, here you can see. So when you click on Lambda 1, you can see the output as foo2. Then it goes to the choice state. In the choice state, we have configured to read the variable foo, and if it is equal to 2, it goes to Lambda 2 and ends the execution. In your Lambda return, which is the last 3 lines basically, and then deploy the code. Let me just show you what happens when you change it to 3. So if you change it to 3 and say deploy it again, and then go back to the step function, scroll top and say new execution, and start the execution. Yeah. So when you change it to foo, when I change the foo value to 3, it's going to execute on this path. Okay. So in your Lambda code, inside exports.handler function, comment out everything except return foo3. So you can have a look at my screen. So it's going to look like this. So comment out all these parts and only make sure you're having return foo2. Yeah. And then if you test it, you should be, if you test it, you should be getting something like this in a Lambda. Okay. So this is how you add services to a step function. And based on how you're passing the inputs and outputs between the services, you'll be able to make simple to highly complex workflows. And just to show you how the visual editor looks, feel free to explore it at a later point in time, but let me just show you what it is, how it works. Okay, so when you're using the visual workflow, on the left side, you can see the action. So these are all the AWS APIs that are supported by step function, right? If you want to use any one of them, just drag and drop it in the editor. And then next to actions, you have flow. So in flow, basically you have all the logic statements that are available by step functions. So let's say you want to add a choice, and then you add the choice over here, and you want to say add an SNS or anything like that. So all that is possible. And the other good part of using the workflow editor is it will provide you the definition by itself. The only thing you would need to do is update the ARNs. So when you go to form and say click Lambda, you need to provide the parameters. So in this case, you need to, for Lambda, you need to provide the ARN, and similarly for other services, you'll have other items that you need to create. So this is about the visual editor. You can have a look at it later. Yeah. So one more last item as part of step function is when you click on the step function, you'll be able to see the executed flows. So this is basically the logs of the item, right? So the executions. So when you click on the execution, you'll be able to see the visual editor and how the flow has happened, whether there's any failure or any such event. And when you scroll down, you'll be able to see the event history. So this is basically all the state transitions or all the things that have happened within the step function. So the detailed log of when it entered, what is the exact data, what was a choice statement made or any other wait statement, the timestamps for all of them. So this is the complete log of your execution. And one of the other things is difference between the standard step function and the express step function is that for the express step function, you will not get the this as part of every execution. As in, you will not get the visualization with every execution, but you will get a log statement. That log will again tell you what all the steps that has happened, but you will not get this visual view for every execution that happens in express step function. So yeah, that pretty much sums up step functions. Any questions or doubts? Okay. So next, we'll see how what is Cognito and how to create it, and use the basic UI that is provided by Cognito to kind of to see how the authentication works. So before that, we have one question. Okay, so one of the step function use cases was building a real-time media conversion software. So in that use case, so what you do is you have a large video file that is being put into an S3 bucket. Okay, so you take that file and then you separate the audio track and the video track, and then split the video files into smaller chunks, convert all the videos into their respective formats, and convert the audio into respective formats, and then combine all of them back together and store them back in all the respective formats in S3, right? So you will get in the raw format, which is basically a studio output. Okay, then you need to convert it into all the mobile, tablet, high HD, HD, Ultra HD, all these formats you need to convert. So this entire process we can orchestrate by using a step function. So this is one of the actual use cases that we have built. Okay, and in this case, because one thing you need to remember while using a Lambda is that Lambda is having a timeout of 15 minutes. Okay, so if there is any workflow that you require that needs to run more than 15 minutes, you'll have to choose a different kind of compute service. So using step function, you have the capability to do that. So what we did was we had a Lambda which is going to do all the parallel task and all the multitasking and those things, and to do the heavy lifting, which is to download files from S3. Right? These files would be somewhere like 50 to 100 GB of size. So if you need to download them, it's going to take more than say 10 minutes or so. So for any kind of these tasks and some of the functionalities, the Lambda would time out. So in these cases, we use something called as a batch. So batch is basically a service that runs a Docker file where you provide what function it needs to do and things like that. So in one single workflow or in one single execution, we combine batch functions, we combine Lambda functions, all of this together to make one workflow that you can track across all the video conversions that happens. So from the time a file enters to S3, so a step function is triggered. From that point, we have in one execution flow. When I say execution flow, like one of these items, right? In one execution, you'll be able to see all the data points that has been translated from one service to another, and what are all the items that has happened. So in this case, what are all the videos it got converted to, what are all the formats of the videos it got converted to, and the final output is stored in S3. So until then, the entire process, you have one single workflow to get all this information, and you have the capability to integrate different types of services together to make sure to achieve the better functionality of the system. Okay. All right. So moving on to Cognito. Yeah. So Cognito is one of the authentication service by AWS. So you use Cognito to provide you the access keys and secret keys. The access ID and the token ID, and you use them to keep your user session active. And with Cognito, you can also integrate third-party providers. I'm sorry. Yeah, so one of the other things of using step function, so the question is whether we can have multiple start points in one workflow. So the answer is yes. So as the first step in a step function, you can create a parallel state. So in that parallel state, you can have n number of items. Say we did one Lambda, right? So instead of that, you want to call 10 Lambdas at the same time. So that is also possible. So those are also some of the features that are available as part of the step functions. So like I said, step function, what we just saw is the basic version of it, or the basic functionality that it can do. But feel free to explore step functions, as every day there's a new use case coming up that is leveraging step function to do a lot of functionalities. Even things like machine learning. So even for that, you have integrations possible, and there are workflows already available to kind of build these types of systems. Yeah. So coming back to Cognito, so you get the access keys and the token keys, and using that you create you maintain these user sessions in your browser. And apart from that, you also have the capability to integrate with social login providers like Facebook, Google, and those kinds of things. And other part of using Cognito is that when you create the user pool in Cognito, you will also after all the configurations, you'll get a hosted UI. So what does it mean, a hosted UI? So you'll get a login page, a login and sign up page, and only thing you need to do is integrate that URL with your web page. And the Cognito hosted UI page is going to take care of the sign-in process, the sign-up process, and sign-up process ideally requires an email verification, right? So including that, so all these processes will happen automatically. The only thing you need to do is configure the Cognito user pool and say that this is what you require. So using all this, you can build the authentication for your application. So now we are going to create one user pool and the other configurations required for it to get the hosted UI. Okay. So excuse me. Go back to your AWS console, and in the search bar, type Cognito. Okay. So open Cognito in a new tab. Here you have two items. You have manage user pools and manage identity pools. User pools is used for creating the users and having their information stored and adding that to the social login and things like that. And identity pool is used when you want to give temporary access, or when you want to attach any AWS service to the access IDs and the token IDs that you're generating. So for us, at this point, it's only user pools. So click on manage user pools. Okay. And then on the right side top, you can see create user pool. Click on that. Okay. Now give the pool name as demo. and then click on Review Defaults, which is the next button at the bottom. Okay. Once you review the defaults, go to the end and say Create Pool. Okay. So just a couple of things that that is there as part of the, in these configurations is in attributes you say through what the user has to log in, like through username, email, or phone number. So that kind of setting, and what are all the attributes that a user needs to provide. Like here we have selected email, and you're free to add any other items as required. Okay. And policy basically tells what kind of username, what's the password length, and that setting, right? Like uppercase, lowercase, special characters. So that things are over here. Okay. And then in MFA, you have whether you want to enable MFA and those aspects like that. And then the important part is the app clients. Okay. So in general settings, go to app clients. Once you have in the app clients, click on add an app client and provide the name as demo. So what is an app client? So app client is one of the Cognito entities that is going to handle your authentication flow. Okay. So after you give the app client name, scroll down, and here you can see the token expiration settings and things like that. And right below ID token expiration, there's a small checkbox which says generate client secret. So uncheck that box. And after that, in the next section, which is auth flows configuration, disable second and fourth checkbox and enable the third checkbox. So you can have a look at my screen once. So disable the generate client secret from the previous section, and in the auth flows configuration, select only the user third item and the last item. Okay. Yeah. So then scroll down and say create app client. So once you do that, you'll be able to see the name and the app client ID that is just generated. And just to make sure that whether we have configured properly, click on show details. In show details, in app client secret, it is not supposed to show anything because we unchecked that box. Okay. And in the auth flows, make sure that only the third and the fifth checkbox is enabled. Okay. So moving on to the next step. So on the left side, under app integration, click on app client settings. So here you will be able to see the, okay, so client secret is, so when you're configuring the Cognito, you will provide, like when you're consuming the Cognito URL that is generated, you will be providing the client ID to it in the URL. So if you're using client secret, you'll have to add other mechanisms to pass the client secret to the URL and stuff. So in our case, we want to keep it simple. That's why we're skipping the step. Right. So on the left side, under app integration, which is the second section, click on app client settings. So this will open the client settings. So here, click on enable identity providers. Right next to that, there's a select all. Click on select all. And next is the sign in and sign out URLs. So let's just keep it simple and redirect it to google.com. So https://google.com. Okay, paste the same in sign out URL. In the next section, which says OAuth 2.0, select implicit grant, which is the second checkbox. And below that, in allowed OAuth scopes, select all of them except phone. So you can have a look at my screen as to all the checkboxes you'll have to click. So the first thing is enable identity providers. You need to click select all. Okay. Then in the sign in and sign out URLs, you can give https google.com. In the OAuth 2, select the second checkbox implicit grant, and in the scopes, you select all of them except for. So just to give an overview, so by enabling identity providers, you're connecting the app client to the Cognito pool that you're creating, and that's why we need to enable that checkbox. Okay. Second thing is sign in and sign out URLs. So like I said, Cognito is going to provide you a hosted UI, right? So it's a different, you're going to redirect to that page. So after you have signed in, it has to redirect back to your application, right? So that is where the callback URL and sign out URL come into picture. So callback URL is after signing in, it will redirect to this page. And when you log out from the system, it is going to redirect to the sign out page. And then coming to the OAuth flows. So this is the default selection that you need to create to be able to use them in the website. So each one of them, again, I'll not go into the details as it's pretty time consuming. So just know that for our use case, we are going to keep it as simple as possible. Okay. So after all the checkboxes are selected, click on Save Changes. So it will save pretty much immediately. And then again, on the left side, under app integrations, go to the second one, which is domain name. Now you need to also add a domain name to make sure that you'll be able to use the hosted UI. Now again, domain name must be unique. So provide a unique kind of domain name to make sure it's working. So after you type in the name, on the right side, you can say check availability. And if it is available, it'll show the message that the domain is available. So select any one of the domains and then save changes. So I'll just give a brief pause for you to type in the domain and get selected. If you have a known domain, then you need to integrate it with ACM, which is Amazon Certificate Manager, and then you can use that. So it would be something like if you are owning google.com, you would have something like auth.google.com that you want to use as part of the Cognito domain, right? So by using, like you can have this user own domain option, and then it is possible to do it. Okay, so after you configure the domain, go back to app client settings, which is the first option under app integration on the left side of the screen. Right. So now when you scroll down to the bottom, you have the hosted UI section, and you can click on hosted UI. Launch hosted UI. So the page that opens up is the default Cognito UI that is available. And again, there are some parts of it which you can customize, but this is the default page that will be shown up. Okay, let's sign up a user. And make sure you provide a valid email ID, because the verification email will be sent over there. Okay, let's just 1 second until I get the verification code. Here it is. Yeah. So once you have successfully signed up or signed in, it is going to redirect you back to google.com because that is the page that we have configured. Now, if you notice the URL, you'll be able to see the tokens. So you have the ID token, and then you have the access token, and you'll have the bearer type and the expiration. So these are all the IDs that you would get by logging into Cognito, and you can use this to keep track of the users. And you can also validate the JWT token. Let me just try to do that. Yeah, so just go to jwt.io and paste the Cognito token. And on the right side, you can see the decoded version of it. So it will give you the details of what is the Cognito pool, what is the username, what is the email ID, and if you have added any other attribute as part of creating the Cognito pool, you'll be able to get that information. So the flow is that so you have to sign up first. So since this is a new Cognito pool that you have created, there won't be any existing users. So you'll have to sign up. Okay. So when you launch the hosted UI, okay, like since I have already logged in, it's going to just ask me if I want to continue as that person. Or so in other cases, you'll be signing up, right? So in signing up, it's going to ask for a username, password, and an email ID. So you need to provide a valid email ID because the confirmation token will be sent to your email ID. Okay, and then keep that username, password. Using that, you can sign in. So I have signed in as Sandy. So once I sign in again, it is going to redirect me back to this configured URL, the callback URL. Okay, to sign in, it's going to redirect you to Google, and then you have the tokens over here. So if you copy the ID token and do a validation on it, like if you decode the token, you will get this information, which is basically the username, email ID, and things like that. So the ID token is in the URL. Right. Okay. Just to reiterate, so once you have configured the domain in Cognito, on the left side, you have app integration. Under that, you have app client settings. Open app client settings. Scroll to the bottom of it. You have the launch hosted UI option. You click on that, it's going to redirect you to the hosted UI. There you sign in or sign up. Based on that, after that, it's going to redirect you back to the Google page with the tokens. So in an application flow, or in the application that we are building, the flow is that as soon as the home page opens, we ask the user to log in. When they click on login, it's going to redirect them. Yeah, I'll explain this. So in our application, we have integrated the Cognito, right? So as soon as you go to the home screen, it's going to ask you to log in, right? When you log in, we will redirect you to the Cognito hosted UI, which is this page. Okay, so after you sign in or sign up, it's going to redirect you back to the application. When it is redirecting back to the application, we will get the IDs, which is the Cognito IDs, right? Then if we decode this ID, we will get information as to the username, the email ID, and things like that. Okay, so this ID token, basically, if you go to jwt.io or any other website which is decoding the token, and you paste that ID token, as the response, you'll be able to see the information that you get when a user logs in. So as soon as a user logs into our application, we can decode the ID token and get information as to what is his username, email, and any other profile information that we have done. Okay, so this is with respect to consuming the keys in the application. now that we have created one user, or one user has signed up, so go back to the user pool, and on the top you have general settings. Right next to that is users and groups. So when you click on the users, and it needs a little bit of refresh, yeah, you'll be able to see the user that was just signed up to the system. Okay. And one last thing about Cognito is you have something called as triggers under general settings, I think the 7th section. So using Cognito, you can set triggers every time a user signs in or signs up, or any of those workflows. So you have around 8 or 9 triggers that can be set on different times. And in our application, what we're doing is we have set a trigger for post confirmation. So as soon as a user is signed up successfully, we are going to store some metadata for him in the user database. So we are doing that by calling the post, by setting it in the post confirmation. So this is the section that I was talking about. So you have the Amazon Cognito. Here we are setting a post sign up trigger. So after sign up is successful, it'll trigger one Lambda that is going to store the metadata in the database. So similar to this, you'll be able to create triggers and stuff. Users and groups. Okay, so kind of to reiterate the users part again. So once you open the user pool, you'll be able to see the users and groups. Okay, so here all the signed up users, you'll be able to see them. And here you can see account status as confirmed, right? So if the user has like not confirmed his email ID, you'll see him as an unconfirmed user. So in this place, you'll be able to get the user information, what is the status, and any other attribute if you have added, you'll be able to do it. And you also have a search bar and things like that to get the entire information. Again, Cognito is a fully managed service, so you will not have to worry about provisioning and stuff. And triggers again is something you set based on the authentication. So you can set triggers on, say, pre-sign up and pre-authentication. Basically, as soon as a user logs in for the first time, say you want to add some metadata about that user in the table. So what you can do is you can set something like a post confirmation trigger, and as soon as the user signs up successfully, it's going to send that information to a Lambda. So again, these triggers are specific to Lambda, as in you can invoke only a Lambda for these triggers. So that you can configure in this page. So these are some of the points at which you can configure the triggers. And in our application, we have set a trigger to post confirmation. Okay. So that brings us to the end of section 2. And before we go into the hoster application, does anybody have any doubts? Okay, triggers is in under general settings. It's in the, I think, 7th or 8th point. Post confirmation, do we need it? So all of the triggers are optional. It's not mandatory that you'll have to keep some kind of trigger for it, but you can only set Lambda as a trigger when you're doing it. Like you cannot have any other service as a trigger to it. You can only invoke Lambdas from Cognito. Okay, so let's move to the S3 section, which is hosting the application. And make sure you have the repo cloned in your desktop, because we'll have to upload this folder into the website. In getting started, there's a folder called website, which will be, those files will be hosting in S3. So make sure you have it in your laptop to upload. So go to your console and go to S3. Okay. So firstly about S3. So S3 is a storage service. S3 stands for Simple Storage Service, if I'm not wrong. And this is where you store all your files, all kinds of media files, log files, images, anything of that sort. Okay. And the concept of S3 is that you have something called as buckets. So you create a bucket and then upload files inside the bucket. So what we're going to do now is we're going to create a bucket, and S3 has a lot of features like versioning, MFA delete. You have different storage classes. Like S3 is a very large service. Like there are so many other options into it. So for now, we are going to look at the hosting feature, and we'll see how we'll be able to upload a static website into S3 and kind of host it. Okay. And then go to S3 and click on buckets on the left side. And on the right side, you have a create button option. Click on create button. And S3 bucket names have to be unique. So make sure you have some kind of unique name. Once you give the bucket name, scroll to the bottom, which is the next section is block public access. So uncheck this box because we want to make sure that our bucket has public access because we're hosting it. So we need to make sure that it is viewable by everybody. So uncheck the block all public access, and below that is going to throw a warning telling unchecking this box means you're going to give public access. Are you sure? So just click on the acknowledgement box and say yes. Okay, and then scroll to the bottom and say create bucket. Once you have created a bucket, open that bucket. And here you'll be, this is the home screen of any AWS bucket. So here you'll be able to see what and all files are there. And if you want to upload or edit any file, you'll be able to do it. Now, what we're going to put over here is the website folder that we have in getting started. So I have it over here. So inside website, you have assets, CSS, index.html, and JS. So just copy all that content and paste it in S3. So you can do a drag and drop like how I'm doing at this point. So once you drag and drop, it's going to ask you for a confirmation that these are all the files that you're going to upload. And then say upload. So in the repo, if you go to the home page, you have a download zip option. So click on the home page of the repo, and right next to the code, you have a download zip. If you have not, if you have not downloaded it yet. So download that and go to getting started, and then all the contents inside the website folder, paste it in your S3 bucket. So everything inside the website folder. So all these three folders, assets, CSS, and JS, and the index.html. So once you upload everything and go back to your homepage of the S3 bucket, you should be able to see something like this, like how it is seen in my screen at this point. So I'll give you guys a couple of minutes to do it. Right. So once you upload all the files, it's you'll be able to see it in your demo bucket in this format: assets, CSS, JS, and index.html. Okay. Now go to properties and scroll to the very end of the screen. There you have the static website hosting option. So edit that part and enable the static website hosting. And when you enable that, okay. Is anybody still having issues with uploading the buckets? Okay, so after you upload the buckets, I'm sorry, after you upload the files in the bucket, open the S3 bucket that you just created, right? And then you'll be able to see, okay. We'll just give it some time for everybody to upload the code. Okay. Right. So open the bucket that you have created and you'll be able to see something like this: assets, CSS, JS, and index.html. Then on top, right next to objects, there's the properties button. Click on that. And in properties, scroll to the very bottom of the screen and you'll be able to see static website hosting. So edit that, enable it, and under hosting type, select host a static website. And in the index document, provide index.html, and in error document, provide error.html. Okay, and then click on Save Changes. Now that you have enabled website hosting, if you scroll again back to the very bottom of it, you will you'll be able to see the hosted link. So to enable website hosting, go to your S3 bucket where you uploaded all the files. Okay, then go to the properties. In the properties section, scroll to the end of the screen. When you go to the end of the screen, you'll have the option of static website hosting. Click on edit, enable the website hosting, and then select the type as static website hosting. Provide the index and error document as index.html and error.html, and then save changes. Once you do that, you'll be redirected to the properties page, and then scroll to the bottom of it again. You'll be able to see the website link. Okay, so when you click on that website, you're going to get an access denied error, because even though you have enabled hosting, you have not made sure that your bucket, the contents of your bucket, are publicly accessible. So you need to do that setting. So what you need to do is under permissions, which is the next tab, right next to properties, you have a permissions tab. So under permissions, go to the fifth section, which is access control list. So under the bucket, go to the home page of the bucket. You have objects, properties, and permissions. And in permissions, go to access control list, which is, I think, the fourth or fifth section. Edit the access control list, and in the second one, that is everyone public access, click on give read and write permissions to this item. And then move to the bottom and select the acknowledgement, which says that you know for sure that you're giving a public access to this bucket, and save changes. Now that the bucket is public, you still have to make sure that all your objects are publicly accessible. So S3 has different kinds of permissions. So the public access is on the top level. So it is you cannot even edit ACLs if you have these this setting enabled. So this is on a top level permission. And then you have bucket policy. So bucket policy is if you want to, let's say you want to access the bucket from some other place, like if Cloudfront needs to access S3 bucket, then you'll need to add a policy that is going to give permissions for Cloudfront to access this bucket. Similarly, if you want to do S3 to S3 access, or from another account you want to access, so for any of those kinds of things, you'll have to use bucket policy. And in bucket policy, you can go up to the object level and say fine grain the policies as much as possible. And then in access control list, you provide who and all has access to this bucket. So either it's the bucket owner or public access or things like that. So go to permissions and scroll down to find the access control list, which is the fifth section of it. Okay, there you edit the ACL and provide public access, public read and write access. Okay, one last thing you need to do before you make sure your bucket is accessible, go to the objects and select all the items. So there's a checkbox right next to name where you can select the entire item. And again, on the right top side, you have actions. Under actions, scroll down, the last option is make public. So it's going to ask for a confirmation, say make public. So now all your files will be publicly accessible. Now when you reload the website which was giving an error, you'll be able to see the website that has been hosted. So this is a static website that we have hosted using S3. Okay, so the first thing is going to properties and enabling static website hosting. Once you do that, go to the next tab, permissions. Okay, scroll down to access control list, edit it and give give public access. Basically, the second item, which is everyone public access, give list and write permission to it. Okay, then save changes. Then it's going to ask you for a confirmation whether you understand the change, what you're doing. Like it's going to make it public. Are you sure? So something like that. So click on the checkbox. Yes, click on the checkbox and then save changes. Okay, so once these two items are done, go back to objects, select all the objects, and under actions you have make public, and make sure you have the public. Make sure you say make public and you have access to the entire item. And once you do that, you'll be able to you'll be able to see the website. All right. So after this, we'll move to creating the entire application through the repo that has been shared. So open the repo and fork it to make a copy of it in your repository. So when you click on fork, it's going to create a copy of the repo under your GitHub ID. Okay. Once you have the copy in your account, in your GitHub account, go to actions. In actions, it's going to it's going to give you a pop-up asking you to enable the enable the workflow. So you'll have that item. So click on that item and enable the workflow. Okay. Once you have enabled the workflow, go to settings and go to secrets. So in secrets, you need to add two IDs. So the AWS access key ID and the AWS secret key ID. So make sure you add it with the same name, in the same syntax. So this is also available as part of the README. So you can have a look of the names over there. So AWS access ID and AWS secret key. So yeah, fork the repo, then go to actions, enable the workflow, and then go to settings and add the two secrets. So has everybody done this part? Okay, so once you have done all this, go to the code. So let me just tell it once again. So open the repository and fork it to your GitHub, and then go to actions, enable the workflow. It's going to show you a pop-up asking you to enable the workflow. After you enable it, go to settings. In settings, go to secrets. In secrets, add the AWS access key and secret key. So it would be better if they have admin privileges, because we're going to deploy around 20 to 25 services. Okay, so after you reach that point where you have added the access keys, we'll just give 2 minutes for others to give. So fork the repository, okay, and it will create a copy in your GitHub, okay, and then when you're in that repo, click on Actions. And when you click on Actions, it's going to ask you a pop-up to approve the workflow. Okay, after you approve the workflow, go to Settings, go to Secrets. In Secrets, you need to add 2 keys, AWS Access Key ID, AWS Secret Access Key. And how to add access keys? So create new repository secret and copy paste give the name as AWS Secret Access Key. So these 2 keys you need to create, Access Key ID and Secret Key ID. This is required for programmatically accessing the AWS account. So give the key and value over here. Once you add them properly, you will be able to see it like this. Okay. So open the repo, right, and fork it to create your own copy. So when you fork it, it is going to create a copy of the repo in your GitHub. Okay, and then go to Actions. So for me, it's showing the entire workflow, but for you guys, it's going to ask, it's going to show a pop-up, or it's going to have a window that's going to say, enable, like, this repo has workflows, do you want to enable it? Enable that, then go to Settings, go to Secrets, click on Settings, and left side at the bottom, you have Secrets. Create 2 secret keys, one for AWS Access Key ID and one for AWS Secret Access Key. So were you guys able to follow? Right. So once you have done those steps, go to the home page of your repo, and then go to parameters.json, which is in the home, which is in the root level itself. So in the root level, right before template.yaml, you have parameters.json. So open that and edit that file. So make sure you deploy in US East 1 for now. Okay, and provide a Cognito user pool ID, and you need to make sure that it's unique. So maybe add your name as prefix or something to make sure that it doesn't conflict with other user pool domains. And give an S3 bucket name. So this is the bucket that we'll be using to host the actual website, and provide a stack name. Okay. Only thing is make sure your region is US East 1, and provide names for them accordingly. Okay. So once you edit the file, commit the changes. Okay. Say I'm just giving a new deployment, but you can give any other. So once you do this, click on actions. You'll be able to see the new workflow that is running in the system. So when you open that, you'll get this thing called as build_deploy. So click on that and you'll see the list of items that is running. Okay, so what is happening right now is that using GitHub Actions, we are deploying the entire AWS service list of AWS services that we want. So the stack name, you can customize it to your requirement. So only thing is it cannot be the same names. That's it. Yeah. So when you start the workflow, the things that are happening inside them are first the initializations like variable declaration and things like that. Then we are going to deploy the CloudFormation stack. So that is going to deploy all the required services. So CloudFormation is basically the service in AWS that we use for infrastructure as service. So you provide a configuration file to CloudFormation, and it is going to deploy all the services and keep track of them. So we are going to deploy the CloudFormation, and after the CloudFormation deployment is complete, we are going to build the React application and push that to the S3 bucket. And at the end of the complete process, we should be able to access the application in a newly created list set of AWS, in a newly created AWS service list. Okay. So in the meantime, while the deployment is happening, let me show you the pipeline configuration file. So you can say click view workflow file. Okay, so the job that we are running is build_deploy. It is using a Ubuntu container instance. And then in the steps, the first thing we are doing is cloning the repo into that specific machine. And then we are declaring the variables. So based on the parameters that you have given, we are passing the same parameters to the deployment. So that is why it's important that these parameters must be changed and must be kind of unique. Otherwise, you'll have a conflict while the deployment is happening. And then under AWS config, we are providing the access key, secret key, basically configuring that environment to be able to use AWS services. And in region, you can see that this is taking from the parameter file, and this is coming from the secrets. So this is why you need to make sure you are giving both of them properly. And here comes the main part, which is SAM. Right. So SAM is basically serverless application model. So from AWS. So it has two sides to it. One side is it provides an abstraction on top of CloudFormation. Like it makes it much more easier to write CloudFormation templates. Okay. And the other part is the SAM CLI, which is used for local testing and deployment. So what it's going to do is SAM build is going to package all the Lambda files that is required that if you are using in the system. Okay, and it's also going to kind of run the check on the template file. And then SAM deploy is going to take these packages, put it in S3, and then build the template file completely and deploy the template. So this entire step is done by this command called SAM deploy. So the SAM CLI is used for these items. Apart from this, you can use SAM CLI to do local testing. Local testing as in you can install it and use it in your Visual VS Code. So there you can, I think you can test Lambda, step functions, and services like that using SAM. So SAM is purely focused towards the serverless side, and it makes it easier to build and deploy items. Okay, so here we're doing the SAM build and deploy. After that, I'm running a small script that is going to, so from the CloudFormation, we are going to get final URLs, right? The hosted link. So we need to send that and the API gateways information to your React application, right? So what I'm doing is using a small script. I'm describing the CloudFormation, getting those files, getting those names, API name, it could be Cognito name or any other name that needs to be updated in the React application. And I'm updating that in the React, that I'm storing a file in React to do that. Okay, so that file gets updated, and after that we build and push the S3 website. I'm sorry, we build and push the React website. So at this point, we use React to kind of build, the Yarn application to build the React application. And then at the end, there's a AWS S3 sync command. So this command is going to copy the contents from the current location and push them to the newly created S3 bucket. So here also you can see that, this is taking from the parameter file that you have configured. Okay, so this is with respect to the pipeline file. It's still running. Yeah, so it is getting deployed. Now, once it has reached the deploy step, this is the CloudFormation that is running. So you can go into your console and see what is happening. So go to your console and select the region as US East 1, which is North Virginia region, and open CloudFormation. Okay, so this is the complete. Oh yeah, so the deployment is complete. So this is the CloudFormation stack, that name that I have given. So if you open the stack, you'll be able to see in the resources section all the resources that we have created as part of this template. So this has like 3 APIs, around 5 lambdas, step function, S3 website, IAM roles, API gateways. So all of this is covered in the template. And one last thing that I want to show you guys is the SAM transformation. Right? So this is the template that we are passing to create the CloudFormation stack. So here you can see, so the template anatomy is that, yeah. So the template anatomy is that you have a parameter section, you have a resource section, and you have an output section. So in parameters, you pass anything external in the parameters, like anything that you want to pass while creating the CloudFormation as an input, and you want to send that to any one of the resources that you're creating. Like say, for example, you declare Lambda as one of the resource, and you create the Lambda name as one of the parameters. So when you're deploying the CloudFormation, it's going to ask you for the Lambda name. Okay, things like that you can do using parameters. And then you have the resources section where you declare the CloudFormation resources. So these of them, correspond to AWS services. So each one of the item you provide over here are corresponding to one of the AWS services. Okay. Now coming to the SAM abstraction that I was talking about. So one of the things you can see over here is AWS : serverless : function. So this is basically an abstraction on top of your AWS function. So this is to make sure that you're able to deploy Lambda in a easier manner. So if you were to write it in the regular CloudFormation syntax, you'll probably have to write some more code to make sure that you're deploying all of these. Okay. So this is before the transformation. So let me show you what happens, what abstraction SAM provides, like before and after. So without SAM, if you are doing it with the actual CloudFormation, and the easiest way to let's say get the syntaxes for any one of the AWS services, just search that in Google. Right, and the first result that comes would ideally be the CloudFormation syntax for it. So when you see this, so these are all the services supported by SAM. Like these are all the abstraction it provides on top of regular CloudFormation items, right? So once you open this, you can go into any one of them and see what data you need to provide, whether it's required, what is the type. So all these kinds of things you can do by doing over here. And there are plenty of getting started with CloudFormation kind of repositories that you can use to get an idea of how the deployment is happening and things like that. Okay, coming to the CloudFormation transformation, say for example, serverless API. So the API that we created and tagged how to do it and stuff, right? So that is what I'm doing over here by using a serverless API. So here I'm just providing a name and the body. So this basically connects all the services and stuff. Okay, so this is before transformation. And after transformation, if you see the process template, this will be a much larger template and you'll not have any kind of abstractions. These would be the actual CloudFormation syntaxes that you need to use. So this is the advantage of using SAM. One is on the CloudFormation side and the other side is the deployment. And now that we have deployed our application, let's see how it is working. So in the output section, you can see the CloudFront URL, right? So when you open that URL, it should show the website. Yeah. Right. So one other last thing. So this is a newly created website with all the items coming from the new website. Okay, and this is the step function that has been created. So now we'll see when we add one of these items what happens. So login, and since this is a new Cognito pool, you'll have to sign up. Okay. So yes. So this is the home page with everything fresh because the database is pretty blind, right? And then you say you request for leave and sick leave. So yeah, in all requests, you can see that it has approved. And in the step function, you can see the latest entry. So in the step function, we're doing the same logic. We're giving we're giving you to a choice statement, and we are providing what is the who's the user from date to date, how many days it is, and things like that. So if the number of days is greater than 2, it's going to wait for approval. If it is less than that, it's going to auto approve the request. So this is with the auto approve because the number of days is less than 1. And then we'll see what happens when we give more than 2 days. Okay, let's say we have 4 days and say vacation. So you can see that in the pending request. Okay, and in the step function, you can see that it is in running state. Right. So this step function is going to be running, it's going to be in this state, running state, until we provide a success response, right? So this is where step function kind of stands out compared to other services, because you can integrate both automated tasks and manual tasks. So think about a loan approval application, right, where there are so many people involved into it. And let's say you want to make sure, you want to keep a proper track of what is happening from the time a person applies to a loan to say it's approved or rejected, right? So you have multiple departments coming into picture. So you can have one elaborated step function. Each one of the step could correspond to any one of the things the department is doing, uploading files, manual checking, whatever it is. And you can use these kinds of wait for tokens and handle any kind of manual process that comes into picture. And this way, it's everything will, I mean, even though there's a manual intervention in between, you still have a programmatic way of keeping track of all the events that are happening in your application. And at the end of the day, you have one single execution keeping track of all the workflows together. Okay. So now it's still waiting for approval. Let's go ahead and approve it. So at the moment we approve, it is going to send the success response. So approve, and in a couple of seconds, you'll be seeing it change to green, and then it's going to update the database. Yep. So just to reiterate the flow, we have 3 APIs. The first API is going to get user information. So based on that only, we are populating what all the requests that he has made before, whether there are any pending requests. So these, and the total number and all those things. So that information we are getting as soon as the user logs in. Okay. Then the second API, which is apply leave. The second API we are calling when we select the date and put a comment and click on this button. So that time we call the second API, and that is triggering the step function that I just showed. So it's going to trigger the step function, and for less than 2 days, it's going to go into auto approval. For greater than 2 days, it's going to wait for manual approval. So now the third API, right? So in the third API, once the user is requested for greater than 2 days, so it is going to wait in this Lambda. That is the blue color wait icon that we just showed, right? So it's going to wait for approval over here. And once the admin approves the request, we are triggering one more Lambda that is going to notify this step function that, you know, continue this. Like, I got the approval for this, you can continue the process. So once that happens, it's going to go to the last step and update the database. So this is the gist of the entire application, and now that's it. So any questions?
I just had one question.
Unmuted.
In the I wasn't able to actually follow along that point. In GitHub Actions, there was a file that you were referring to.
Okay.
I think it was a Docker file. Could you just show me what file it was? I can't seem to find.
Sure. So in the home, in the root directory, you have .github/workflows. So in that you have a main.yaml. So this is the pipeline configuration file.
So this is where you define your CloudFormation workflows, or is this where you where did you make the SAM model like here only, right? In
yeah, it's like you can, using SAM, you can deploy from your desktop itself. Like say when you have SAM configured in your desktop or PC, there what you can do is you can create the CloudFormation template, and if with enough credentials, we can deploy it directly. The reason we're using pipeline is to show the GitHub actions and how we can automate the entire process. So deploying the CloudFormation is step one. Then building the React application and pushing the data, getting the final file. That is, these are all the things that are performed by the pipeline. So you configure the pipeline using main.yaml, but the template file, the CloudFormation template, you can see in the root directory, there's a template.yaml. Okay, so this is the CloudFormation template file. Say, suppose you don't want to use GitHub Actions and say you want to deploy it from your local directly. What you can do is you can clone the repo, install the SAM CLI, okay, and configure the AWS credentials. And from the root, you can do a SAM build and SAM deploy. Basically, the commands that we're running in the pipeline, SAM build and SAM deploy, you can do it from your local also.
Okay. Okay. Thank you.
Not understood that action step in Git, sir. That
Sorry?
action step is not coming in only. Action step, sir. Actions. I first report the this one, sir. File. After that, actions is not coming on this in my PC.
Which like I didn't understand.
Pull request site, sir. Actions. This one, sir. Actions. Pull
Oh,
request.
Okay.
So
over
that,
here,
this
like
page is not coming.
It's not coming. As in, yeah, that's what. Like you will have a tab or something that says enable actions. So I mean, enable
No, there is
workflow.
nothing. There is nothing. It is asking that all workflow and new workflow. It is asking.
Then that's fine. Yeah, so it doesn't necessarily need to ask for it. Like only the first time it's going to ask. So if you have already used actions before, then I don't think it's going to ask. So now that you have it, only thing you need to do is go to the code, edit the parameters and update, commit it. And then when you go to the actions, you'll be seeing this file running.
So how to commit it?
Yeah, but, yeah, before commit, have you updated the secrets?
No, it is not asking. It is not telling that secrets is not coming only. It is showing that environmental secrets and repository secrets. There are no secrets for this repository.
Yeah, you need to add. Yeah, that is what you need to add.
What to add, sir? So manage environments and environmental secrets.
So in secrets, right side top, you have new environment secret. Right? Yes. So there you need to create two secrets. One is for the access key and key ID, and one is for the access key. So these two things will have. Sorry?
Yes, name and value. What is name and what is value?
Yeah. So the access key ID. So in the README you can see, right? So you need to create one for AWS access key ID, one for AWS secret access key. AWS access key ID is the key that you need to give, and value is the ID that you generate in your IAM.
Where it is, sir?
So in your AWS console, you need to get the programmatic access for the AWS console. Right? So
maybe we can take this separately because some of these steps will take some extra time as well. And then you need to go to your AWS console, IAM user, get this access key and secret key first and configure back to the GitHub. So maybe we can actually continue with some of the other things, and then this can be done separately. That is possible.
Okay, can you tell afterwards?
Sure. Sandeep, what we can use another 5-10 minutes if anyone has any generic serverless related questions. This workshop now, as you from your side, it is done. As a last for the last step, we will make the session video soon available. I don't have the exact time duration when it will be available, but it will be soon available, and you will be notified over the email as well. But if any of you has any generic, just a serverless space related use case related question, now is a good time. Sandeep will be able to answer many of those. Again, this is a short duration, and these services, all of these services have evolved a lot in the last few years. So you will see that all of these are very extensive services if you go to the documentation and kind of features that they cover. But if you have, feel free to ask any question in general related to serverless or anything related to any of the services that Sandeep has covered so far.
So the Cloudfront, Cloudfront, you can tell about the cloud permission and Cloudfront.
Okay. So yeah, so Cloudfront is basically a CDN service, which is basically content delivery network. So that's something that is going to sit at your end customer facing point. Okay. And Cloudfront has something called as, AWS has something called as edge locations. So edge locations are basically Cloudfront's caching network. Okay. That's like to put it in a layman term, it's like a data center where Cloudfront is going to store the information. That's to put it in a very, very simple manner. Okay. Now, what happens is Cloudfront can be connected to an S3 bucket or any other kinds of source, because Cloudfront is only used for caching and stuff, right? It is not going to have the source. So the source comes from somewhere else. So in our case, the source is the S3 bucket where we are actually putting up the files. Okay. And using Cloudfront, when the first user access, like our website is hosted in Mumbai region, for example, and we have a Cloudfront location in Bangalore region. So when a user from Bangalore requests for the first time, the request will go to the Mumbai region and he'll get the files from that region. But after that, Cloudfront will cache the files in the Bangalore region so that any other user after that who's going to come in is going to get the data directly from Bangalore region. It's not going to take from the main this one. So this is by using Cloudfront, you can make all these caching happen. Yeah, and what was the other service? CloudFormation.
CloudFormation.
Yeah, so CloudFormation is a service you use to handle infrastructure as service. Okay. So what you do over here is write this template file. So you can find this file in the repo. There's a file called template.yaml. So this is the CloudFormation file. Okay. So using CloudFormation, you write this file and provide this file to CloudFormation. It is going to create something called as a stack. In that stack, based on the template that you have given, it is going to create and manage all the resources. So when I say manage, so first step is to create these resources, right? And then let's say tomorrow some change comes and you want to update or add more resources to it, you can update the same file and deploy it. So it's going to update the same stack with the next set of services. And suppose some few services got deleted previously, you can go and delete them, and it will automatically delete and add those services. Only thing you need to do is update the template file. So the management of resources is and its lifecycle is possible by using CloudFormation. I think we can take one last question before we wrap it up.
Yes. Go ahead, Sandeep.
Sure.
Yeah. Okay. No, go ahead. Sorry. Hello.
Yeah.
Yes, please go ahead. I was going to say the same.
Oh, sorry. So I had a question about the you talked about step functions being, so is it always used with respect to flows, like for example sign up or leave approval? So it will be modules in my application which I would want to sort of manage or sort of keep track of using step, like what role step function has in this application, or any, like what would be a sort of a real world use case for step function? Like I think you sort of touched on it briefly, but like why would I need to know where my flow is in I mean, you talked about, manual and loan and all of that. I mean, in that console, how often am I going back and checking where a particular loan is in its state, whether it's pending approval? I mean, don't you have CRMs for that? Like from the AWS console, why is tracking where a particular flow is necessary? I mean, like you said, like in the example that you showed, we were trying to you were trying to approve a leave that was more than 4 days. So I'm just saying, what is this console like? What is the real world use case for this console? That's all I wanted to know. like this would be something that the attendance system would have its own internal CRM, right? Where the person who approves would go and see, okay, so and so person has asked for an approval for leave, and he approves it. He's not going to come to AWS, right? Because there'll be multiple such histories of flows, right? Like you have this history of all the there's this history page where all your step functions are sort of logged. So I just wanted to know, what is this used for in a real world application, which is being used by maybe tens of thousands of people?
Yeah. So the current example is for a simple use case, right? So it's just to show that you can kind of integrate your synchronous and asynchronous process like a manual workflow into the same item. But one of the real world use cases is a real-time media conversion that I spoke about some time back, right? So in those cases, instead of you going and checking the logs and the system as to what has happened and everything, you can just query the execution, right? When you query the execution, you will get the entire process flow as what has happened. So with that, in one execution flow, you get the entire set of information. You don't need to have any other things to do it. So this media conversion thing that I was talking about, it's converting into 33 formats, right? So that into your video chunk. So video file is say 120 minutes. So you have like a 200 or 300 lambdas running. And how would you keep track of all these lambdas, right? If you have to build why do you have to build a separate mechanism for it when AWS is offering a direct mechanism for us to do it?
Okay.
Yeah, and one more thing I would recommend is in the state machines, like when you create the state machine, you have sample projects. So you can have a look at them, and these are based on the real use cases and the new ones that are coming up. So AWS keeps adding them. You can have a look at it to kind of understand it better.
Okay.
Yeah.
If you have time, can you tell about that Git, sir?
Sorry, about?
Git, sir. GitHub, that action, sir.
Okay. So I'll just go through it very shortly. So when you're creating, yeah, sorry.
For me, it is not showing that the actions in your page. It is showing that actions. In my page, it is not showing.
That will have to sit on it separately. I don't think
so. Yeah. So Sandeep, I would suggest, yes, guys, we have given you the coordinates of Sandeep. Actually, if you need any help, he's available and he can reach out on his LinkedIn profile, and I'm sure he will be more than happy to assist you on that. Yeah. In the interest of time, I think we need to just wrap this up because we are almost 38 minutes over our time. Yeah. So really appreciate that. Over to you, Dhaval. You can close the call. Yeah.
Sure. Thank you, Toshal. Thank you, Sandeep. Now, what I would suggest, Sandeep, if you can just stop sharing your screen, and everyone else, please enable your video as well.
Yeah.
That will be a good way to end the session. There were lots of questions, and we hopefully, I mean, we answered a lot of them. There are still few open questions, which we'll try to answer later on. But we all hope that you all enjoyed. You learn something new. Serverless is one of the fastest growing space. Besides the Docker, Kubernetes, DevOps, if you just see the overall traction, you will see that all the major cloud providers, the third-party tooling services, different private clouds, they are all offering the serverless services, managed services. All of the services that Sandeep covered, they are quite broad. They have a lot of features. So depth-wise also, they are covering a lot of things. So I hope that we gave a kind of nice overview of this if you have not done anything with that in past. But this will help you to extend your knowledge in the serverless space and actually explore with the different use cases. Sandeep works for another awesome company, Antstack. So please do check out his profile, the company profile as well. They do a lot of activities. They have a lot of webinars going on every now and then on LinkedIn as well. So please follow us on the LinkedIn as well and keep stay updated. So before we close up, there is a feedback link that I have pasted. Please give us your feedback, constructive feedback. We don't mind whether it's positive or it's negative, it's neutral. Everything is for the sake of learning. We are all just trying to learn something new every day. The credits will be shared later on. The session recording will be also shared later on. There is a Amazon voucher as a kind of a gift for the fees that you have paid for this session that will also be shared later on. Don't worry, nothing is going anywhere. You will receive whatever we have committed, so don't worry about that. I hope you all have enjoyed the session, and we'll see you soon, one or another way. So that's it from my side. Toshal, you want to share anything?
No, I think you shared it, I think, very aptly. Dhaval, you being very humble. I know I follow you from very long time. Okay, so for everybody's information, Dhaval is our serverless expert. Yeah, he's certified on all the AWS certifications. Yeah, and he runs Surat AWS community. So do follow him as well. Okay, you will get a lot of learning from Dhaval as well. Yeah, and we have our team, Atul, Gargi. Yeah. All of them, yeah, you do follow them, and they have put in a lot of efforts. Yeah, so yeah, to kudos to all the team, and thanks for all participants, and special mention for Sandeep, who has taken a lot of efforts to bring you the content he has shared today. Yeah, so thank you very much, Sandeep, and everybody have a nice day. Yeah, thank you very much. Thanks. Thank you. Bye.
Thank you.
Thank you. Thanks, Sandeep. Bye.
Build. Go. Build. Go. There is no compression algorithm for experience. Def and test are the most important workloads. Dance like nobody's watching. 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 Encrypt like everyone is. There has never been a better time to build. There has never been a better time to build. You build it. You run it. 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 You build. You run. You build. You run it. You build. You run. You run. You run.